All right, so moving into electrolytes. This is actually pretty important for the section where we talk about acids and bases and the other types of equilibria. It's not like we don't need to have it done then, but it is important to have some idea of what these things actually are. And I think you probably have some idea. So we'll talk about electrolytes shortly. There are three types of solutions that we can have. You can have a solution that is unsaturated. Unsaturated solution. And so this is going to be kind of solute versus solvent situation. So unsaturated solution, which is going to have more solute can be dissolved. So it hasn't reached a maximum yet. You know, if you put a little bit of sugar in and you want to make it, if you think, I use like iced tea as an example. So if you have some tea and you put a little bit of sugar in, it's slightly sweet, but you can always make it sweeter, and you're not going to get that buildup of sugar on the bottom. That would be considered like an unsaturated solution. Easy enough. The next step to that, as soon as you add enough sugar that you see sugar start to pile up on the bottom, you are going to have a saturated solution. So a saturated solution where the maximum solute is dissolved at that temperature. So this is going to be, these are all temperature dependent, but that saturation point at a certain temperature, we reach that saturation point. And there's a maximum amount of solute that can be dissolved at that specific temperature. Any additional solute remains solid and on the bottom of the container. So if I asked you to make a saturated solution of some kind of, if I had, okay, make me a saturated solution of salt water. So you don't have to know the actual concentration, like solute point at that temperature. What you simply do is you take the salt that I asked you to make it with, you load it up until you see stuff starting to pile up on the bottom, and then you just decant off the solution. So making a saturated solution is actually really simple. You should always see a pile of solid on the bottom. So those are the two major ones, unsaturated and saturated solution. There is a special case where you can actually have more solute than should be dissolved. We call that a supersaturated solution. A supersaturated solution is the circumstances where you actually have more. First of all, it is unstable. It means that some small disruption can potentially make it become a saturated solution, can make things crash out of solution. The solution is holding more solute than it should. And the example I can use for this is, have you had sweet tea before? Sweet tea is something that's really popular in the South. And the way that you make it is you heat up tea, you add sugar, and then as it cools down, that water is still holding that sugar. It has not crashed out of solution. But if you tried to add the same amount of sugar to cold water or cold tea or just room temperature tea, it is not going to dissolve that much. It's going to pile up on the bottom. So the supersaturated solution has a special way of creating it. So you have to heat it up and let it cool slowly so that stuff doesn't crash out of solution. You should look up supersaturated solution. I'm not going to show it here. I probably should have put a link in. A supersaturated solution of, let's see, it is, sodium acetate or potassium acetate. You should check that out. There's a very cool reaction where you add one crystal and it crystallizes the whole thing. It's one of the things that I do for like the magic show. But yeah, take a look at that. Okay, so saturated, unsaturated, saturated, and supersaturated. It's just different levels of how much solute is allowed at that level. And we're going to take a look at a couple of graphs that will kind of put this more in context at specific temperatures. There are three types of solutions in terms of electrolytes. So again, this is about electrolytes. We know the type of solution. So there are non-electro. So these are the solutes. I guess we can probably classify all of the things as the types of solutes, solute types that we can have. So first one is a non-electrolyte. So these are relatively simple. So we have to memorize, we have to remember what an ionic substance is, things that can form ions. So a non-electrolyte is none of those. It is when dissolved, they do not dissociate into ions. So things that are non-electrolytes but can still dissolve. So if you take a look at a sugar molecule, we know that sugar, solid, we drop it in some water and it turns into sugar aqueous because it has dissolved. And the typical sugar is usually 4 or 5 or 6. We've got an OH, and then along here, so it's a hydrogen here, and then we have OHs above and below. And I've got a bunch of different cases, H, OH, H, OH, OH. So why do we think that this thing is really capable, this sugar molecule is capable of dissolving in water? Well, we have a bunch of these OHs. All of these OHs are perfect for dissolving because they're gonna go through hydrogen bonding. Sorry, Bela's back there chewing on stuff. So sugar dissolves in solution, and it does so because it dissolves it likes to interact with water molecules. So when we're looking for, when we see non-electrolytes, assuming they can dissolve, we look for organics. Okay, organics. So anything with like carbon, X, hydrogen, Y, nitrogen, halogens, oxygen, any combination of those. This is how I identify an organic. So first and foremost, when you see carbon and hydrogen and you see a bunch of them, then we identify those as organics. I should also say organics are going to include a bunch of basically non-acids or bases. So if you have a bunch of, again, I recognize an acid as carbon or a hydrogen out front, and then we've got some stuff after it. So if you see that hydrogen first, that is going to be an acid, and that is going to be an electrolyte. So we're going to ignore that. So non-acids and bases, anything that's not an acid or a base is going to be a non-electrolyte. And you'll get used to those, but ultimately you're looking for a bunch of carbons. If it starts with carbon, it's generally going to be a non-electrolyte. Okay, from the other side of the spectrum, we're going to take a look at strong electrolytes. So non-electrolytes are the things like sugar or organics. They dissolve in water, but they don't dissociate into ions. If we look at strong electrolytes, they completely dissociate. Into ions. So the best example I could give is sodium chloride turns into Na plus aqueous plus Cl minus aqueous. How do I identify stuff as ionic or non-ionic? Again, we identify those as metal and non-metal is going to give you ionic or non-ionic. Metal and non-metal, there's your ionic compounds. Okay, so the strong electrolytes, you remember that solubility table? So if you remember the solubility table, the ones that are soluble, those soluble salts, those are all strong electrolytes. Anything that's soluble is considered a strong electrolyte. So any nitrate, remember there's a handful, like nitrate and acetate, those two are always going to be strong electrolytes. Also the list of strong bases, which we've talked about before, strong bases. And the reason that I include the strong bases next is because they are on the soluble list in the solubility table. So if you know the solubility table rules, you don't need to memorize bases as well because they're included in the above. So just to remind you, group 1 and hydroxide. So sodium, potassium, right? Lithium, rubidium, cesium, all of those hydroxides are kind of considered strong electrolytes, as well as the heavy group 2s and hydroxide. So calcium hydroxide, calcium strontium hydroxide, and the last one was barium. Yeah, barium hydroxide, calcium strontium barium. There we go. So strong bases, again, those are on the list of the solubility tables. Okay, so strong bases. And of course, the strong acids. These ones you do need to know because they're not anywhere to be found on the solubility table. So strong bases, again, HI, HCl, HBr, the halogens, the heavy halogens minus HF, HCl, HBI, HR, the HClO3, HClO4. So the oxo ions, the mineral acids of the chloride, HNO3, H2SO4. And that is the list right there. So those are the ones you got to know. Okay, so those are all considered strong acids. So those strong acids, the soluble things on the solubility table, those are going to be our strong electrolytes. They completely dissociate in solution. We have a one-sided arrow, everything turns into ions. We don't have to worry about considering anything else. There's no equilibriums going on there. Everything is ions. And then we have weak electrolytes. These things partially dissociate. So these are the ones that we're going to spend the most time on because these are the ones that have equilibrium. Equilibrium chapter generally leads to looking at partially dissociation into ions. So the example here would be something that we don't recognize. HF is a weak acid and it has a partial dissociation into H plus and F minus. So it does break into ions, but not that much. So the list here includes, and I guess before we continue and talk about the list, so this is what it dissociates into. And so I say complete dissociation, that means 100% of it is ions, 0% of it remains as sodium chloride solid. When I'm talking about the weak dissociation, HF, the weak dissociation of into ions, I'm talking about 95 to 99% of it is is ions, and like 5% of it is HF. And this is considered a really strong weak electrolyte, as in usually it's like 0.1% is actually dissociated. I got that backwards actually, sorry. 95% of it is not dissociated. So usually we have only like 0.1% that dissociates. So that number is depends on what you're talking about. Okay. In terms of the list of things, well, the insoluble salts, they're not totally insoluble, they're partially soluble. So those salts that are on the solubility table, if they're partially soluble, then they're going to be included in the weak electrolyte category. Weak bases, these are a little bit harder to recognize, and you start to recognize them as you get better. But the weak bases, so first of all, if it's not for the hydroxides, non-strong bases, and you're going to see a lot of this non-strong hydroxides. The best example I can give you is generally a metal that is not group 1 or heavy group 2s and hydroxide. So like, as an example, something like iron hydroxide, that is considered a weak base. It only partially dissociates. The other popular ones are NH3. This is kind of the go-to. This is ammonia. And any organic with NH4, basically with nitrogen. So some nitrogen NH, X. So if you see a what we call an amine group, yeah, so this is known as an amine. That is going to be considered a weak electrolyte. So something like CH3, CH2, NH2, that is a weak base, and that will in fact dissociate in a number of ways. So bases that are not strong, essentially, and then finally, weak acids. So we're looking for, again, we see that H out front, right? So, but non-strong. So something like HCClO, a hypochloric acid, that is going to be hypochlorite. That's going to be a weak acid. And the other one is organic acids. And organic acids contain that COOH group or carboxylic acid group. You might also see it as CO2H. Those are the two ways you could see it. Okay. So those are the electrolytes. If you can identify them, that's like half the way. So one more time: unsaturated, saturated, supersaturated, and then solute-types: non-electrolyte, strong electrolyte, weak electrolyte. Get used to that solubility table. You're going to need it. And next, we're going to talk about the idea of solubility.